The application of color to socks can be done in fiber, yarn, or garment form. All dyestuffs used for various fibers in piece goods dyeing can be applied to socks. Before the yarn or sock can be dyed, they must be prepared to remove any unwanted materials. Cotton socks need to be bleached before dyeing to remove their natural off-white or cream color. Here you see a grayish sock on the left with the natural color of cotton fiber. The sock in the middle is post-bleaching, and the sock on the right is post-dyeing. Preparation of cotton fibers, yarns, and socks to undergo dyeing and finishing processes is critical, since a high percentage of all problems appearing later can be traced back to inadequate preparation. Regardless of the substrate, whether it's fiber, yarn, fabric, or socks, the first step of preparation is to scour, to remove unwanted impurities. Scouring provides other benefits, improving absorbency and ensuring that the cotton is uniformly clean. For white shades, the sock has to either be made from bleached yarn or, if made from grayish yarns, bleached. If a light to medium or bright shade is desired, the sock will also have to be bleached. For example, the sock on the left is made from grayish cotton with its natural cream color. The middle sock is post-bleaching, and the sock on the right is dyed tan. If a dark shade is desired, the grayish cotton sock might only need to be scoured and not bleached. Bleaching is a critical step and is employed to produce a uniform white base so that light or bright colors can be achieved. There are a number of chemicals available to produce the whiteness achieved by bleaching. In most cases, hydrogen peroxide is used. Peroxide bleaching offers distinct advantages, providing good whiteness, economy of use, and flexibility. In the past, sodium hypochlorite was used in sock dye houses. However, handling and potential strength loss problems have made hydrogen peroxide the primary choice. Dyes are defined as highly colored materials that can be applied to a substrate to impart color with some degree of permanence. As previously stated, color can be applied to the fiber, the yarn, or the sock. To better understand the principles followed in dyeing a substrate, let's identify the basic stages or steps involved. In the initial phase, a substrate is placed in a medium, most often water, to which dyestuffs and auxiliary chemicals are added. Dyes are adsorbed to the surface of the substrate and diffuse into the fiber. Once inside, dyes migrate or level out and are then fixed to the fiber. To increase color fastness and obtain consistent shades, some type of after-scouring or cleanup is required to get unfixed dye off the surface of the substrate. There is more to dyeing than obtaining the desired shade. The color must be durable, and the dye must exhibit good fastness to future wet treatments. It is critical that color be consistent from yard to yard, piece to piece, lot to lot, and from lab to production. Many socks are made with yarn dyed into a solid shade. In this scenario, the dyed shade must be uniform throughout the package, or barré or color flashing will occur in the sock. Let's now take a look at the various classes of dyestuff. Fiber-reactive dyes form strong covalent bonds, which result in good wash fastness. Different chemistries used for this type of dye display different levels of fixation and resistance after dyeing to such factors as acid, alkali, chlorine, and hydrogen peroxide. Aside from excellent fastness properties, fiber-reactive dyes come in a wide range of colors and can be applied with different methods, which are easily automated. A second type of dye commonly used for cotton is direct dyes. They are economical to use and offer a wide range of pastel shades with excellent light fastness. However, because these dyes are attached to cotton fiber by weak bonds, direct dyes exhibit limited brightness, poor chlorine fastness, and poor wash fastness properties. After treatments can be used to achieve adequate wash fastness properties. In contrast to direct dyes, types of dyestuff known as vat dyes produce good wash fastness properties. Here's why. Vat dyes have no initial affinity for cotton and need to be changed chemically or reduced to make them soluble and absorb and diffuse into the fiber. Once inside the fiber, vat dyes are oxidized back into an insoluble form, making it less likely that the dye will wash out. Vat shades tend to be duller, more neutral shades, such as khaki and green, or dark shades. Vat dyes do not offer the full shade range of color that can be obtained with direct and reactive dyes. Vat dyes in general have excellent light fastness and in most cases are not sensitive to chlorine. Also, when washed, color can be rubbed off because these dyes are sensitive to abrasion. Similar to vat dyes, sulfur dyes are easier to reduce but harder to oxidize. In addition, the shades available are similar to those of vats. Sulfur dyes tend to be inexpensive but are sensitive to chlorine and are subject to color loss with abrasion, which leads to poor crock fastness. In light shades, they also possess poor light fastness. On the other hand, they exhibit good light fastness in darker shades and are widely used for navies and dull green shades. For black in apparel, sulfur sets the industry standard. As you've seen, there are a variety of options when dyeing cotton. Each dye stuff has its own strengths and weaknesses. The final decision of which to use is based on customer requirements and supplier capabilities. A tremendous amount of socks are knit from dyed yarns and yarn spun from dyed fiber. Fashion is the primary driving force. In small sock manufacturing operations, socks can be made from dyed yarn, knitted, scoured, and boarded for sale. This greatly reduces the costs of manufacturing in that complete dye houses do not have to be part of the mill's operation. The use of dyed yarns is common for ingrains and jacquards. It is also used in functional areas such as reinforcement for abrasion, cushioning, logos, and other uses. The color of the yarns does not necessarily improve the performance, but is an indicator that the performance is built into the product.